This video will be covering how we read digital and analog data using the Raspberry Pi. Firstly, let's talk about analog data. Analog data is an integer representation of a physical value, for example, lightness. Sampling is used to turn such physical values into numbers, which represent a different state in a range of possibilities. As Raspberry Pis have a range from 0 to 1023 to represent this, we can infer that a light room may be represented by a high number, such as 800, and a dark room, a low number, 40, for example. Here, you can see the Raspberry Pi. The analog input device is connected to the analog pin A2. In this circumstance, we're using a light sensor. In the code, we merely read the analog input and output the resulting state. As this state is printed, you can see the effect that covering the light sensor has on the values. They increase and decrease with different physical values of light. The data read could then be used to trigger certain events. Let's say this is part of a house security system. Drastic changes in light that aren't gradual over the day could suggest an intruder in the house, and these integer values could show if the light changes. So what about digital data? Digital data uses voltage levels to estimate if an input is in a state of high or low. The binary values 0 and 1 are used to represent this. For example, let's say we have a digital input, a button. When the button is not being pressed, the voltage level will be low and the binary value 0. When it is being pressed, the voltage level would raise, causing the binary value to become 1. These changes in value can be used to trigger certain outputs. Here we have the Raspberry Pi. The digital input device, a button, is connected to GPIO pin D4 and can be pressed when required. The code simply checks the state of the button, and if it is pressed, returns the binary value 1. As the button can either be pressed or not pressed, we can see the value shift from binary 0 to binary 1. But why would this be useful? Imagine we have a doorbell. A press of such button could trigger a bell to ring, so we need to know the different states. Thank you for watching. I hope that now you understand the difference between reading digital and analog data and how the Raspberry Pi can do this.